everyone. We are Group 2 of EC444 Smart and Connected System of Boston University, and we have for you a smart pill. What it does, it's a pill that will be ingestible. It goes into your body, and it sends out information about what's happening in your body. It could tell the orientation of the pill, whether it's vertical or horizontal, and it will also be able to send information about the light intensity and anything else that could be a good use case for this smart pill. We are using an ESP32 board that has a few sensors and modules to it. We have a photocell sensor that will be able to tell us the light intensity. We have the buttons. We have a reset button, another button that when pressed will be able to tell us whether it's horizontal or vertical. Obviously, in practice, this button will not exist. It will just send us information as to whether the pill is vertical or horizontal and where it's located.
We do encounter a lot of difficulties during the development process. For example, like when we design the hardware interrupt into our the whole system as the reset button to reset the whole system to redo the whole cycle again to know whether it's in the body or not. So what we encounter is that our LED doesn't work and our button doesn't do the hardware interrupt correctly. So what we do is you introduce a new feature. It's called QUI, using this task in our code. We successfully managing to get rid of any possible problem we can encounter with buttons and successfully send it to the send it between the inner files, which is also included in our group repo.
How it works is when we connect it to our programs, the green light will on. Is that means it's ready to swallow up. And when we put something cover the photo cell, which means the environment become dark, and the blue LED will blink for every 2 seconds. And also when we remove our fingers from the photo cell, and it become bright, and which means our program is done, and the red LED will turn on.
So for the hardware part, we are using 3-color LEDs indicating different function, and we are including 10K resistor in series with all the thermistor and all the photocells, and also using it to detect the voltage at the specific time, so it generates readings. So we also use the ADC pins on the ESP32, which read the analog readings from the from the thermistor and the photocells.
Let's talk about our code flowchart for the software. At the start of the program, it's gonna measure all of this sensing data from all the components, and then it's gonna entering the first state, which is ready to swallow the state, and it's gonna turn on the green LED at the same time. Then it's gonna check the condition if the light intensity reach the threshold. If it exceeds that, it's gonna entering the second state, which is normal sensing data. It's happen when the patient swallow the smart pill into their body, and then it's gonna start to display all the data in the terminal, and then it's gonna check the light intensity again. If it's exceed the threshold, it's gonna entering the third stage, which is out of the body, done sensoring, and it's gonna turn on the red LED instead of blue LED. For the reset button, if it is pressed, it's gonna reset to the first state. If it's not, it's gonna stay on the current state. And that's the end of our program.